Great. Well, hi everyone. Welcome to our May 2026 GIST Forum. I'm Dylan Abney. I'm an ontologist at Semantic Arts, and today I'm going to speak about gistBFO. So what is gistBFO? One way to think about it is that it's a BFO-compatible version of GIST, which is the upper ontology that we develop at Semantic Arts. So it allows you to use GIST as your upper ontology, just as you typically would for building out an enterprise domain ontology, and then you get alignment to concepts in the basic formal ontology by inference. Some of the motivations for creating this alignment are well described in a white paper by Dave McComb, Semantic Arts CEO and co-founder. And then this eventually became a collaborative project with myself, my colleague Kate Styczynski, along with a group of ontologists from the National Center for Ontological Research, including Giacomo D'Acole, Finn Wilson, Federico Donato, and John Beverly. So at Semantic Arts, we took an initial stab at this alignment, but ultimately we wanted to get input and support from those who are most familiar with BFO. So we did that. A little bit more about the background motivations. So really the idea behind creating gistBFO was to create something that would allow people to leverage the strengths of both GIST and BFO. So with GIST, you have a core set of common sense concepts that cover just about anything you might see in an enterprise information system. So it's a great starting point for domain ontology development. BFO has become a baseline standard in the defense world. It's also commonly extended for ontologies in biomedical domains. More and more, it's used in cybersecurity as well. So there's this growing demand for alignment with BFO. In addition to the compliance aspect, really a more fundamental motivation is interoperability. So we wanted to combat against ontology silos from developing. To give you a better sense of what I mean by that, you can imagine one ontology that's extended from GIST, maybe a pharma company enterprise ontology, another ontology which is extended from BFO. And at this point, there's no expectation that the data that is mapped to each of these ontologies will be interoperable. You can run a single query and get insights from both of them. However, if instead you use something like gistBFO and you import that into this pharma company enterprise ontology, then you've got this bridge between the ontology that's developed initially using GIST and the ontology that was developed using BFO. You could potentially run a single query that would generate insights across both data sets, which are mapped to these ontologies. So a roadmap for the rest of the discussion today. I'm going to start out with some background on GIST and BFO for anyone who's not familiar. I'm going to talk about ontology mappings and alignments, get some terminology out of the way. I'm also going to talk about general methodology that we use to produce gistBFO. I'm going to take a closer look at the alignment itself, some of the individual mappings within the alignment. Also talk about some challenging cases, things we had to think about a bit to arrive at the correct mapping. And then I'll close things out with some ideas for future work. And if anyone has questions along the way, feel free to interrupt me. I'm not sure if I'll be able to see hands, but if you have any questions or need any clarifications along the way, feel free to interrupt. Okay. A bit of background on the basic formal ontology, BFO. So BFO, it's very small, upper level ontology. Currently in the BFO 2020 OWL version, it consists of 36 classes, 40 object properties, and 602 axioms in total. It's used by over 700 open source ontologies. It's an ISO certified top level ontology. It makes use of a hub and spokes approach, and so it's designed to be extended. Even though its classes are quite abstract, It's designed to be specialized. Some of the key classes, if you're looking at the very top level of the BFO class hierarchy, you'll have the entity class, which includes everything that exists or has existed. From there, it breaks down into two very general classes, continuant, which includes things that persist, like a baseball, things that persist through time, that is, and occurrence, which are things that occur in time. So those would be things like events, like a baseball game. So you got those two general types of things. I should note here too that I'm using, these aren't the actual IRIs within the ontologies. Within the BFO ontology, I'm using some human readable IRIs here for convenience. This is one slice of the BFO hierarchy that I wanted to show for those who are unfamiliar, just to give you a sense of the types of classes that would fall within the ontology. This is the continuant side, so it doesn't include occurrence like events. This is just everything that persists through time. And so it's got a lot of coverage. It's got things like objects, aggregates of objects, which are material entities. It's got immaterial entities like spatial regions. It's got various qualities or features of objects. And so it's got all that coverage. But one thing that you see relatively quickly is that if you don't have a lot of knowledge of the terminology here, you don't know what these things mean, it could be a challenge if you're trying to map enterprise data into these categories. It's tough to place things within buckets unless you have some deep knowledge of what these categories mean. So what about GIST? So GIST is a business-focused ontology. Its scope is pretty wide. It covers most things, but a little more limited than BFO. It's focused on the types of things you're likely to encounter in enterprise information systems. It's been developed and refined over the last 15 or more years, and it's been used in over 100 commercial projects. It's really designed to facilitate stakeholder buy-in and understanding, and it's designed to support rapid modeling. As of our latest release, which was last month actually, we released version 14.1.0. Just had 97 classes, 66 object properties, 50 data type properties, and approximately 1,500 axioms in total. So a bit more on the class count and the property counts, and there's a richer set of axioms included in the OWL. But overall, both of these ontologies are relatively lightweight. Here's a picture, just a slice of the GIST hierarchy to give you a sense of some of the types of classes that you would see in the GIST hierarchy. Things like person, living thing, which are both subclasses of physical identifiable item. Something like intention or collection, organization, event. These are all common sense terms that if you're trying to map enterprise data into GIST, it's a little bit easier to know which bucket something is going to fall into at the outset. And so that's what we mean when we say, GIST is really a Kickstarter for developing domain ontologies. Okay, moving into some of the methodology for the alignment that we produced. There's a distinction we can make between mappings and alignments. Sometimes these things get conflated, but in this context, we're trying to be specific about what we mean by mapping and alignment. Ontology mappings are the individual subclass and subproperty assertions that relate classes or properties in one ontology to another. And then the alignment as a whole is just a set of ontology mappings. So you can see in the diagram here, this is just an example of a very small alignment that includes 4 ontology mappings. The 2 on the left-hand side are subclass assertions, and the 2 on the right-hand side are subproperty assertions. The first subclass assertion is that all commitments in GIST are BFO continuants. And similarly, all GIST specifications are instances of BFO's generically dependent continuant class. Say more about that in a little bit. And then similarly, you can make assertions for properties. Turned out that BFO's has participant property was a subproperty of gist's has participant property. So some of these were relatively easy, but we've got both of these types of assertions, the subclass and subproperty assertions within the alignment. So in total, we developed 43 logical axioms, 35 of which were subclass assertions between gist classes and BFO classes. We had 8 subproperty axioms in total, and all of the classes within gist have a superclass within BFO. And we didn't map all of the properties, but we took some key properties in gist, some that we use very frequently, they're kind of core to gist, and we did map those into BFO. And we'll talk a little bit about those in a bit. The alignment itself is available on GitHub, so you can go out to the Semantic Arts GitHub, you can download this, you can plug a domain ontology into it, you can import it using an import statement and develop from there. Gist BFO itself, the alignment with all of its assertions, imports both gist and BFO. So continuing with methodology, how did we go about selecting the individual mappings to include in the alignment? Our initial work on this made use of something that was very helpful, this BFO classifier tool, which really provided a decision tree for us where we could ask a series of questions about something and we could arrive at a candidate superclass in BFO relatively quickly. So for an example, blueprint, which is a stereotypical instance of the gist class specification. We asked, first, does this entity persist in time or unfold in time? And we said, well, it persists. So a blueprint is a BFO continuant. The next question we had to ask was, is this entity a property of another entity or does it depend on at least one other entity? It seemed like the answer was yes to that one. A blueprint depends on another entity, namely a sheet of paper to be represented. And then finally, may the entity be copied between a number of bearers? And it seems like for a blueprint, absolutely yes. It can be copied across multiple sheets of paper. So a blueprint is a generically dependent continuant. In fact, if you look at the annotations for BFO's generically dependent continuant class, blueprint is listed as an example. And so this made us think, with blueprint being a stereotypical instance of specification, that GDC would be a good candidate superclass for specification. And indeed, that's what we ultimately selected. So we use this as an initial guide. Now, as we developed methodology for the alignment over time, we tried to keep some important properties in mind. We thought of them as design principles. And we've got a list here. First and foremost, we wanted the alignment and the union of the alignment in gist and gist BFO to be logically consistent. So it can't entail any logical contradictions when you run an OWL reasoner over it. Similarly, we wanted it to be coherent in the logical sense where it doesn't entail any unsatisfiable classes or properties. None of the classes end up being a subclass of OWL nothing. We wanted it to be conservative in a very specific sense, which is that we didn't want it to entail new things within the language of gist or BFO. So we didn't want it to change the meaning of gist or BFO. And you can think of an example, if throughout the mapping process, we ended up with an axiom like gist person is a subclass of gist event. If that popped in when we ran the reasoner, that's not in gist right now. But if it were entailed by our mapping, that would be very questionable. We think, well, this is kind of adding something that wasn't previously there. It's changing the meaning of gist person. So We wanted it to remain conservative in that sense. We also wanted the mappings to be specific. We wanted to take the GIST classes and map them to the most specific superclass that we could within BFO. We also wanted it to be faithful, really to respect the intended meanings behind the terms in both GIST and BFO. And to ensure that, we had to take a look at the formal definitions. Sometimes that was talking with stakeholders, developers of GIST and BFO, and sometimes also looking closer at annotations. So that could be sometimes a challenge. Did want to point out this paper, which talked about a project of aligning the provenance ontology to BFO. They had a lot of discussion of these types of desirable properties of alignments, and so that was a helpful resource for us in developing this list. A bit more about specificity. So why is it important that the mappings be specific? Well, one thing you could do, this could be an alignment, is you could take every class in GIST and say it's a subclass of BFO entity. And that would be an alignment, just wouldn't be a very interesting one, right? And if you're trying to ensure BFO compliance, this, sure, maybe it's BFO compliant, but not in any real sense, right? To illustrate how we applied faithfulness as we developed GIST BFO, take a class like GIST organization. Our question was, where do we place this in the BFO hierarchy? We had a couple of candidates. One was immaterial entity, another was object aggregate. And the reason you might think that GIST organization is a subclass of immaterial entity is that you might understand an organization as something more than just the aggregate of its members, and that it could be something that persists even without members. So if it's something over and above its members, the question is, what is it? Is it something immaterial instead? The problem with going that route is that immaterial entities in BFO cannot have material parts. And it seems like organizations do, in at least some cases, have material parts, namely their members, in at least some cases. So we thought, well, maybe it could be a subclass of object aggregate. And we actually, for some of these mappings, consulted the Common Core ontologies, which are a suite of ontologies extended from BFO that have a lot more concepts that are similar to GIST. And they have an organization class in that ontology that maps to object aggregate. So we thought, well, to be consistent with the Common Core ontologies, we might point GIST organization at object aggregate as well. If you're thinking about organizations in this way, you're just thinking about them as kind of groups of members. And that implies that if an organization loses all of its members, it ceases to exist, which could be a downside. Now, we then thought, given that there are pros and cons to each of these, we could just generalize to say that organizations are independent continuants. We're not saying anything more specific than that. We just know that they're independent continuants. But this has the downside, of course, of being less specific. So all of those things considered, we ultimately opted for object aggregate, given that we could maintain consistency with the Common Core ontologies. And also we figured that this was the predominant sense in which we tend to be thinking about organizations in GIST, and that these organizations that persist without members might be more of an edge case. So kind of for practical purposes, we opted for organization as a subclass of object aggregate. The mappings ranged from simple subclass assertions. So here's an example, a few different examples of GIST classes in green here and BFO classes in blue. Physical substance is a class within GIST. An example of an instance would be like a lump of clay, and that rolled up to material entity. So that was a subclass of material entity. Specification, as we've already discussed, like a blueprint would be a generically dependent continuant. Something like a temporal relationship would be like an ownership over time. If you wanted to express that a person or an organization owns an asset for a particular period of time, you might use a temporal relation. And within the BFO framework, that's a relational quality. This gives you a sense of where the properties were mapped. The properties were interesting because we actually, the more specialized properties were actually on the BFO side. Um, with the classes, it was the reverse. Within GIST, the classes are more specific than the BFO classes. But on the property side, in part because BFO has domains and ranges on properties, those ended up being more specific than the GIST properties, which tend not to have domains and ranges to promote reusability. But as you can see, properties like has participant map to the GIST version, or BFO's proceeds property map to the GIST proceeds property. The reverse direction doesn't necessarily hold given those domain and range restrictions. But again, this was limited to most of the core properties that we tend to use fairly frequently in GIST. So they range from the more simple ones to more complex. And on some of the mappings, instead of using just a basic subclass assertion, we made use of property restrictions. And a good example of this was controlled vocabulary. It ended up being a subclass of the intersection of generically dependent continuant and the class of things that have a continuant part, some generically dependent continuant, namely a term. So you could think of controlled vocabularies as themselves being GDCs and having parts, the terms, which are also GDCs. So when we could, we would add in a little more information to try to make the mappings as rich as possible. Another interesting case was gist intension, where to place that within the BFO framework. A couple of subclasses of gist intention are gist function and gist specification, as we've discussed. Functions fall under specifically dependent continuant. In fact, there's a function class within BFO, so it made a lot of sense to place just function under SDC, and specification rolls up to generically dependent continuant. So the question is, where does gist intention as a whole go, given that some of its subclasses point to different disjoint superclasses within the BFO framework? And so ultimately, for pragmatic purposes, we opted for a union superclass. So gist intention became a subclass of the union of specifically dependent continuant and generically dependent continuant. Event was another interesting case. So event, we initially thought, okay, well, this will be an easy one. We'll map it to BFO process. In fact, I think event is an alt label for process in the BFO ontology, so it seemed like a natural candidate superclass. We started to look closer at the subclasses of gist event, and there was an interesting case, scheduled event, which is kind of like a future event. Doesn't have to have happened yet. And thing about BFO process, though, is that it doesn't include within its extension future events. It's only, I think, contemporary and historical events. And so we had to think about if we've got to put scheduled events somewhere within the BFO framework, where do they go? And we thought, well, maybe they could be thought of as more of a plan or a specification for an event. So we opted for generically dependent continuant. GDC is disjoint with process, and so we opted again for the union construction for pragmatic purposes here. In some more discussion with Dave about scheduled events, I think he still tends to think of scheduled events as being genuine events, not plans or specifications necessarily. They're events that happen to occur in the future. So bearing that in mind, I think there's an opportunity for refining this particular mapping over time. But at the time, this mapping made some sense. As for future work on gistBFO and other related mappings, we want to make general improvements in accordance with the design principles, particularly with specificity and faithfulness. So that's like a big part of this is, we want folks who are familiar with BFO and familiar with gist to give input on this to make sure that we have the alignment correct and that it's useful and that it's faithful to the intended meanings of the terms in both of the ontologies. We're also interested in creating some richer mappings. So what I mean by that is like we've got the subclass assertions and subproperty assertions. That kind of gives you a base level of interoperability. What would be really cool, I think, is if we had something that's expressed purely in gist. So it's using all gist properties and classes, and then that could be translated using a rule language like data log or something of that nature to something that's purely described in BFO. So there's an opportunity for richer mappings to be developed over time. We're also interested potentially in alignments with other ontologies, if folks would find value in them. So talked about the Common Core ontologies, which rolls up to BFO. We've looked into that. It seems like it could be a more challenging project, given that it's at the same level of abstraction as gist for the most part. So there are good questions about how those classes relate to one another. So CCO is one option, another is UFO, and we've been doing some work on that recently to align gist with the UFO ontology. Okay, so I will stop there for questions if anyone has questions.
Well, Dylan, if I may.
Yeah.
So
Sure.
one question I have concerns this very high level distinction between continuant and occurrent. And I mean, this is kind of it's a common metaphysical distinction. I mean, other terms we encounter a lot are the distinction between endurance and perdurance, but it's essentially the same thing. I mean, the idea is it's the distinction between an object that is wholly present at a time, like, say my coffee cup, and persists through time, and an object, and something that is extended in time, like this webinar that can be subdivided into temporal parts, which my coffee cup can't. But the critical thing that this brings into play is the critical distinction, or a critical distinction, is that with continuance, there are going to be facts that are true in some temporal contexts and not others. Like, for example, my coffee cup right now is sitting on my desk. It wasn't this morning, and it won't be this evening. Whereas with occurrence, at least some relations, like temporal relations, the fact that this webinar temporally subsumes my drinking from my a particular instance of my drinking from my coffee cup. Those relationships, in some sense, hold timelessly, right? I mean, they are they are fundamental facts about four-dimensional space-time, if you will. This suggests that this distinction really, in some sense, almost presupposes temporal contextualization. I mean, the reason for having it is you want to be able to distinguish facts that need temporal qualification and facts that don't. But that in turn implies that you've got some way of handling context. And as far as I can see in RDF, there are really just two ways to do it. You either have to deploy nodes that denote other RDF triples, and there are various ways of doing that. I mean, you can use named graphs, for example, or you have to go to something like RDF star, which basically just bit the bullet and allows qualification and allows quoting, in fact, of RDF triples. Are you looking at and is there interest in maybe at the semantic arts end in introducing some kind of contextualization for just BFO down the road?
Yeah, I mean a lot of what you say I agree with. I think there's we have pretty standard ways of representing the types of statements that you've mentioned here within GIST. And so, as RDF 1.2 becomes more pervasive and gains more support, we may gravitate towards other ways of representing things, but that's kind of to be determined. However, in those cases where we want to represent that something is in a particular place for a given amount of time, often you could use a temporal relationship. If you don't really care about the time boundedness of something, then you might place it with a direct relationship. As far as overlap of events goes, typically we've got event instances which will have actual start and end date times, and you can sort of calculate the overlap or represent the overlap by using queries to see how how events overlap or whether they do or don't, that sort of thing. So I think you're correct that often there's an interest in picking up on those temporal aspects of facts or relationships. We do have some ways of doing that now, but I think probably open to other ways of representing it in the future, depending on the use case. But that's just my 2 cents on that. I'm sure others will have opinions as well. I do see some other hands. Michael Sullivan?
Yeah, this might be nitpicking, but so blueprint's a continuant, right?
Yeah.
But what about a version to blueprint? In other words, one that's been superseded and is no longer valid. Is that a continuant?
Sure.
Okay. What about a legal document that's been amended? Is the previous legal document a continuant?
Sure.
Or are we splitting here?
It still exists. It probably still exists. It may not
but
be
it's not legally binding anymore. So what? I think I'm splitting hairs, but I just wanted to.
I think that's a separate relation, though, right? Like if it's legally binding as opposed to if it exists as a continuant.
Mm-hmm.
Yeah, we tend to separate the document from the commitment. So the commitment goes away, but the document stays around.
Mm-hmm.
Excellent. Okay, thanks.
Rebecca.
Yeah, so I wanted to ask about, so my understanding of the overall enterprise here is to allow somebody to extend GIST or describe their data with GIST and have it sort of automatically connect into BFO. But when you have things like BFO properties being sub-properties of GIST properties, or a GIST class being a subclass of the union of two BFO classes, you're not able to make that connection. So what is, I mean, is that really a useful part of the mapping?
Yeah, that's a very good point. And I agree with that, certainly on the properties, because you're right that in that case, it's not a matter of representing something in GIST and then you get inference into BFO. So the property alignment, I think, was done more in the spirit of better understanding the relationship between the two ontologies, which is sort of a background goal, I think. But right, you're not getting that kind of inference. It's not serving that kind of use case. Now, as far as the more complex mappings of the classes, I think the downside of those is that they aren't as informative necessarily as like a straightforward subclass assertion. So you're left with, okay, well, this now I know this thing could be either
Yes.
a specifically dependent continuant or a generically dependent continuant. What do I do with that?
Yes,
I
exactly.
Yeah, and I think it could depend on the particular domain, but my my sense is with the axioms acting together, there could be cases where if you know something is not an SDC, it could get inference into the GDC class. So
That's
it's
true. Yeah.
that's me kind of hand waving and speculating, but that's the type of scenario that you could
Yeah,
have
okay.
when it becomes more
Okay.
informative. Yep.
Thanks.
Brian.
Hi, I'm a data engineer who's learning how to apply ontology,
Awesome.
and I work at a bank, and I am working on building an ontology for our bank.
Mhm.
I've been kludging together FIBO, CCO information artifact ontology, and the document ontology.
Yep.
It looks like you guys, I mean, this seems promising. I'd like to have kind of one thing to reason about, one set of things.
Mm-hmm.
To what extent, if I were to rewrite all my code to use your gist, I like BFO. I've been learning a lot about it. I like the whole University of Buffalo ecosystem. I think it's super cool. So I want to stick around with BFO. I like what their Barry Smith is putting down, and so I think that's important and useful. To what extent, if I were to adopt this, do I need to be worried about future improvements breaking my integrations? Is this ready to rock? Is my question.
Yeah.
Yeah.
Yeah. So one, it is in active development. So currently it is aligned to version 14, the major release of GIST. We're going to try to keep that in sync as we update GIST. Typically, at least on the major versions and probably for the minor versions too. If you wanted the latest version of GIST, you'd be able to get support with that. So that's the goal. And so if you were to start using GIST and taking the data you've got, aligning it with GIST, then yeah, it should be ready to go. Rebecca.
Well, I was just going to follow up on that. I assume you're also using SemVer with just BFO, right? And you're doing releases the way we do with GIST?
Yes, we are. So we have official GitHub releases that you could use there. And
yeah. So in answer to that question, I mean, that's why we do versioning and releases, is so that you can import a specific version. And then even if, we have a major version, let's say that's not backward compatible, you can wait until you're ready to update to the latest version. Just like software.
Yep.
Sorry, just quick follow-up to that. Is that a kind of problem? I mean, from you guys were doing this in Semantic Arts, like, is that a problem that's likely to really break my work, or can these things be resolved, in a more or less trivial way?
Well, if you don't change the version, it won't break your stuff. And whenever we release a new version, if it's a so-called breaking change, we usually send a little script with it, say, here's how to update your data.
And you can tell,
Okay.
like I said, we use semantic versioning, so from the version number whether it's a major release. But yeah, major releases are not backward compatible.
Hey, Dylan. I just
Hey,
wanted a
Christian.
quick question. Good to hear from you again. Always a pleasure.
Yep.
So I wanted to just ask, with gist and all, the future of alignments and stuff like that, I see you had, UFO, CCO on there. I guess my question is, like, where do you see gist falling in for, say, somebody who's using BFO already, and maybe they're already using parts of CCO? What's the selling point for you to like say, hey, use gist, like why don't you use gist for this part or here and there? I guess like what sort of gap are you trying to fill with doing all these sorts of alignments with gist?
Yeah, it's a good one. And certainly if somebody's already gone down the path of aligning with or extending from CCO, it's a good question of why you might switch to gist. I think one of those reasons which I hinted at was stakeholder buy-in, and quick and quick domain ontology development. So if you're looking to move into other domains and you want to quickly model those, I think gist is going to be a good option. It's also, if you're trying to communicate to stakeholders, like, here's the ontology I've developed, here is where your data fits into a data model. I think gist is going to be a good tool for that, for them to look at their data and say, okay, yeah, I recognize this. I see how it's interacting with the other data, and things are making sense here. So that's my initial thought on that question.
Oh, thank you very much.
Yep.
I just want to quickly add to that. I mean, I've never used gist, so this might be wrong, but I've had experiences where CCO can sometimes be like too much for people, or there's too many modules to work with. And it seems like a good use case here. It's just easier to explain what's going on instead of having to dig through 30 modules to figure out what fits your specific use case.
Exactly. Yeah.
Appreciate it.
Yeah, once upon a time, we had about a dozen modules in gist. We'd gone down that same thought process, but two things happened. One, many of the concepts migrated up to the top, and then a lot of them, which was just over specification. So it eventually, through evolution, just evolved to what Dylan showed at the beginning of this. And we do think it's a lot simpler to get your head around.
Other questions, comments? Yes.
Yeah, hi. Thank you, Dylan. Very good talk. I'm not sure exactly how to phrase my question, or maybe it's just a thought, but I thought it was quite interesting that you mentioned those schedule events. And I should say I'm not an ontologist, but you said it's not a plan specification, right? But if you have like a schedule event that is on the continuant branch, right? Because it's a type of information of what should happen at that event, right? You have a plan for what should occur. I see that is sort of a plan specification, right? Because it's sort of encodes what should be done and what should happen and what step you have. And then you can then choose to follow that, or you can fail to follow that when it really unfolds in time, right? In your current branch. So I just thought that perhaps it should. So yeah, I was just wondering about it should be a plan specification, perhaps or not. I was just trying to mold over that logic.
Right. Yeah, it's a tricky case, and it goes back to that question of where, if it's not a process, where does it fall within BFO? And we thought it could be a generically dependent continuant, maybe because you could think of it as a plan or a specification for something. In fact, that if you're trying to model out something before it's actually occurred, that could be a lot of what you're interested in. Like when am I planning for this thing to start? On the other hand, I think that there's utility in having a single IRI where you start with the scheduled event and its class changes over time depending on the context. So it can go from a scheduled event to becoming a contemporary event to becoming a historical event. You've got a single IRI that has very similar properties all the way through that process, and that makes a lot of sense too. So Rebecca, did you have some similar thoughts on that?
That was part of what I was going to say, but we also do have an event specification class, which is
right
in the specification hierarchy, sub-hierarchy. So that is somewhat different. So like an event, as Dylan was saying, can kind of accrue information as the planning continues. First you get a start date, then you get a venue, then you get attendees and so on. And we don't want to have to change the thing every time. And also a scheduled event remains a scheduled event, even when it's a past event. It was still an event that was scheduled.
Right.
Yeah, thanks for that insight.
In fact, that's a great plug for our upcoming event, which is the Data Centric Architecture Forum. And it is one IRI. We have been planning this for months. We've been putting attendees on it, and we don't want to suddenly, the morning of the event, say, oh, that's not a thing anymore. We got a new thing, and move everybody over. No, it just becomes real as you do it. It's the second week of June. If anybody wants to come out here to Colorado, DCA Forum.
Is that going to be a real event, Dave? Or?
Yeah, of course it's going to be real. It has to be. We've taken money from people. Those were actually taking money was real historical events about a scheduled event.